Refactoring to clean code vlog number 3 after a very long time. If you are watching it, it means that code quality matters to you. My name is Włodek. I am a person that takes care of code quality, and that's what I share with my different roles. I am engineering manager, coach, and I also deliver technical workshops. In this vlog, we are going to divide a big class into a few smaller ones. So the code will become more and more extendable. We will deal with God-object Antipattern. I hope you remember or you have heard a little about it. It is a class that is growing and growing forever when new requirements are coming. We will work with piece of code, so definitely, guys, you are expected to download them and follow me, do exactly what I will be doing or even more on your laptops. So at this point, stop for a while this recording, go into GitHub link, download the sources, and then we will continue. So now I assume you downloaded the sources. As you see, each vlog is associated with beginning and ending version of the sources. So now we are focusing on vlog number 3. As you see, it is a public repository, so you can download it at any time, make a branch or copy it into your repository and do even more different refactorings. Here is the source code. As you see, we have a few classes, a few tests definitely, and one class, God-object Antipattern called person, that does too much. What it does? Stay tuned, we will go through this piece of code together, but before, let's come back to the basics. What is clean code and what refactoring is about? The basics matter. So what is clean code? Or maybe what it isn't? So what is bad code? You know it very well, right? Bad code is something you don't want to touch. You want to change the team, you want to change the project, at least in your company, because the code that you work with is very difficult to extend, to change, to reuse. So you want to avoid it. In this case, what is clean code? Clean code must be something that is easy to extend, to change, test, or it's not that difficult to take a piece of code and use it for some slightly different reason, but it's the same logic, so you can reuse it. In this case, how to keep your code clean? I'm not sure if it is a good question, because bad code is part of our lives. So the key point is to be able to notice that, oh, something is going wrong for future requirements and I need to redesign it. And here refactoring comes into the scene. So what is refactoring? Refactoring is nothing else but ability to distinguish between bad code and clean code. If this piece of code that you have has sufficient architecture, so we can work with it and put new requirements into the project. You have two paths in general when you have a new requirement. Either you perform the change like on the left side and then you clean it, but it is slightly risky because lots of people forget about cleaning because it works. So I have new functionality, it works, so why shall I bother with cleaning it? So it is better to have a look, prepare your code for extension, clean it, and then gently inject new functionality or perform the change that is required by your stakeholders. What is the business domain about of this project? I've chosen something that is easy to understand. It is a system that is dealing with accountancy for a nursing house. there are different people involved in running such a house. Doctors, nurses, first of all, but also volunteers, even visitors. And all of them has access cards, and we will be using events from these access cards to count the money, if there are some, that we owe to pay to these people involved. Everything is done by person class. Let me open it. And it is a class that does all the computations. Currently it is not that big yet. As you see, it registers the time, begin work, end work. It can count the minutes, the night hours, and it counts the salary, nighttime supplement, and so on. But new requirements are coming. And it is a question, if we have new requirements, shall we leave the design as it is, or shall we change it? The first two requirements, overtime and sick leave. Let me come back into IntelliJ. As you see, get overtime minutes, get overtime salary, get sick leave salary. They seem to be not implemented, so even if you implemented them in the same style, like copy-paste, do something, most likely you will not break anything. But on the other side, if you come back into contractor accountancy, the last requirements, where contractor is not an employee, so they might have different rules, the design might require some redesign. Here is a set of new requirements. And these requirements are good reason to stop and think if the current design of the code, if the current architecture is sufficient and allows us to inject these new requirements gently, nicely into our code. Maybe it is the case, maybe it isn't. Let me have a look. Overtime and sick leave, the first two requirements. Overtime salary, sick leave salary, not that bad. As you see, these are two empty methods. So even if we implement them in a conditional code style, most likely we shouldn't break anything. But on the other side, coming back into the last requirement, which is contractor accountancy, then in order to implement different rules for contractors, let me show you the different rules. Here it is, your homework, slightly different rules for contractors. It looks like to implement it, we will be modifying existing code. Do you remember that code should be open for extension but closed for modification? So in this case, most likely changing these conditional statements might be risky or might lead to some issues. In such a case, please join my invitation to live refactoring together this piece of code, so we will prepare it to be able to implement safely new requirements. What are the concepts we have in our code? We have employee, intern, volunteer, and on the right side, different components we calculate. Base salary, nighttime supplement, bonus coins, sick leave and overtime accountancy are missing. Are these concepts visible inside our code? We have a person class that has a few methods. So it looks like the computation concepts are visible, but how about different types of person? I am not sure if they are that visible. Most likely when you look at this one, cooperation type, enumeration, you can see that different person might belong to different cooperation type, but I think as lots of conditional code is based, as you see, on these cooperation types, we can try to create additional few classes. Let's do this. Person. Option enter, create subclass, employee person. One more. Option enter, create a subclass, intern person. The last one. Volunteer person. At this point, I am pretty sure you might ask, why are you introducing inheritance? That's true, I agree, but trust me, we can think about this later. Now, I wanted to introduce additional concepts: employee, intern, and volunteer. It might seem a next point that contractor person will be the subsequent step at some point. Let's put all three classes into additional new package called people. Let's put now all three into people. Oh, there is some issue. Nighttime regulation. What's wrong with it? Let me have a look. Nighttime regulation. It is a record. So let's make it public. I think that now we should be able... Oh, this one should also be public. Now I think all three subclasses can be placed in the subpackage. Okay, we have people subpackage that contains three concepts. These concepts are not used yet. Teaching the existing code to start using these three subclasses instead of a person class, their base class, might take some time. So what can we do to start using these three classes? We can introduce factor methods. Let's introduce the factor method then. How shall it look like? I guess it will be something like this: a static factor method that returns one or the other or one of the others classes. But wait, it contains conditional logic. Is it fine? According to Uncle Bob, factor methods are the only places where you are allowed to use conditional statements. Here is our IntelliJ. Three classes: employee person, intern person, and volunteer person. Nighttime regulation has been made public, and here is person, a class that is currently subclassed. Let's run the tests. I should have started with it, definitely, but I forgot. As you see, we are live refactoring. So let me check if everything is fine. Yes, it is. It is fine. So in such a case, factor method is missing. Here is the person class, its constructor, which is currently protected because the subclasses are placed in a different package, a subpackage. So let me create a factor method. Option enter or alt enter, replace constructor with factor method. Click enter. We have it. I think that as this one is going to replace one of these three classes, not the person, I think that we can find a better place for this one. In this case, I will create one more class called person factory. I will put this class here. I will move the factory method there. So here is my factory method, create person. F6, move this one into person factory. Oh, what's wrong? What's the issue? Person is protected, will not be visible. I think it will be visible. Let me check. No, this one is not visible from here. Option enter, make it public. Or make it public for a while, I guess. And create the switch. Return switch based on cooperation type. I think I can quickly ask IntelliJ to generate the cases for me. Create missing branches. So in case of employee, I guess I will return employee person. In case of contractor, oh, this branch doesn't exist yet. In case of intern, it's intern person. In case of volunteer, it's volunteer person. But I guess constructor is not needed as of now. Yes, so otherwise constructor is not implemented. Case contractor, throw new exception. Do you think our tests are green? Let me check. No, some of them aren't. What's wrong? Oh, I see. Contractor. So maybe in such a case it would be easier, I guess, for a while, as it is not used, as you see. Get rid of this one. Let me check again. Everything is green. In such a case, let me have a look again at this one. Create person. It returns person. Okay, now this is the entry for the outside world, a public method that returns 1, 2 or 3, the first one, the second, the third one. But I guess that most likely they even don't need to be public. This one doesn't need to be public, and this one they don't need to be public. Here is the entry point to create person. Which one? One of these, but the outside world will talk to the base class. I think that this constructor doesn't need to be public any longer. Protected is definitely enough. This way we achieved having factory method and the options hidden inside the package. If you are using Java 17, we have one more option of limiting the subclasses, the set of subclasses. It was achieved here through a factory method that returns one of these three options, but it could be a sealed class that permits only all these three subclasses, like interperson, employee person, and volunteer person. That's another option. Definitely you could do this, although I do not see currently too much gain, because all of them are present in a package and are hidden inside the package. The next step will be getting rid of conditional logic. Currently, it's the person class that contains all the computations and conditional logic, whereas I would like to make the most use of the classes that I've created: employee person, volunteer person, intern person, and put only the relevant parts of the conditional logic inside them. Let me continue. Here is our person class, the class that we apply the majority of changes. The computation methods are placed at the bottom. These are the methods that I want to push down into these three subclasses. In order to do so, I go into the big refactoring menu, push members down, this one. I mark these 5 methods and click refactor. Oh, there is an issue. Okay, I guess that these methods require person.type, this field, and most likely something more. Let me quickly come back and check. I guess here it is, cooperation type. Yes, it cannot be private, it will be protected. And most likely this one needs to be protected as well. And then these methods that require, as you see, these fields type, shift, hours, duration, can be pushed down. Let me try again. Ctrl T on Mac, Ctrl Alt Shift T, here is the menu, push members down. One, two, three, four, five methods. I will keep them abstract in the current class, but the content of these methods will be pushed down. Click refactor, click continue. Let's have a look. Here is the employee class, for example. Here is the intern person class. They contain duplicates of this method. But in a minute we will solve the issue of conditional logic. Before, let's run the tests. Still green. Yes, everything is green. As the final step of refactoring, in this episode we will remove dead code, dead branches. We pushed some conditional logic down into the subclasses, but only one single path for each subclass is always executed. Let's have a look. Employee person. This is employee person. It means that this is the case that is always executed. If it is employee person, the type cannot be different than employee. And in such a case, Here it is, the only valid case that is always executed. Remove unreachable branches. How about this one? Return switch type. The type is always employee. In such a case, this is the only valid branch. Return 0 as of now, and the last one, employee. Here is the only reachable branch. Here it is. And as you see now, employee class does not contain any conditional statements. Intern person. Let's do the same. So this one is here, it is always intern. Option enter, remove unreachable branches. This one, it is intern. Option enter, remove unreachable branches. And finally, switch. This one is intern. Option enter or Alt enter on Windows, remove unreachable branches. Here it is. And the last one, which is always volunteer. Option enter, remove unreachable branches. Return 0, definitely a volunteer does not get base salary. Volunteer. Volunteer doesn't take nighttime supplement. It always returns 0. So it looks like this piece of code is also redundant. Overtime salary, sick leave, oh, but volunteers, do you remember, are getting the bonus for coins. To eat something, to drink good cup of coffee. Here it is. This way, as you see, we removed the dead branches. I hope that code review is part of your software development process. In such a case, let's quickly recap what we have done. We have a new requirement and we decided to choose the right path. So we adjusted the code architecture and now it should be quite easy to add new subclass of person class that is here. Yes, one more subclass, contractor person. And then you should be done. You injected new block of code into the existing architecture, adjusted architecture. As a homework, try to do this. Why not? What's the point of only listening to this vlog? Of course, this episode could not cover everything, so I plan to continue. Most likely, the first thought that comes to my mind is to get rid of this inheritance and replace it with delegation. But maybe you have your own suggestions that I should cover as the first point. Therefore, see you in a few weeks most likely. If you like this video, please share it with your friends. Hopefully your friends are not too busy to stop for a while and focus on code quality. You can leave a comment, and if you are really shorted of time, please give a like to this video and see you next time. Thank you.